In this video, I will present the right-hand rule for finding the magnetic force on a particle or a wire with current. Now, big warning on this one. So if you are looking at the textbook, Walker, the right-hand rule that I'm going to present here is not compatible with the one that's in the textbook. In this case, you have to decide, are you going to use the right-hand rule that's given in the textbook, or are you going to use the right-hand rule that I give in this video? The fingers and thumb mean different things. All right? That's huge warning here. If you are familiar with cross products, so mathematical cross products, this will be easier for you. This first equation, FB is QVB sine theta, that is actually this in cross product form. So if you understand cross products, you can look at this and figure out the directions. If you don't know cross products, that's okay. That's what this video is for. So the way this works is in a cross product, we've got things in three different directions. Magnetism is inherently three-dimensional. We can't learn it in one dimension and then expand to two dimensions, expand to three. You have to start with three dimensions. And the way we do that is by using our right hand. So your right hand has to be set up just the way it's drawn here. Okay? So right hand, put your left hand in your pocket, do whatever you have to do to make sure you're using your right hand so you'll get the right answers here. So the palm of your hand, if you think of how you push things, if I want to push something, I will generally use the palm of my hand to push. So hopefully that makes this easier to remember, that the force is in the direction from the palm of the hand pushing out. The direction of the thumb points in the direction of V. All right? So if something is moving that way, okay, put your thumb in the direction that it's moving. So palm is in the direction that the force is going to be when something is moving in the direction that your thumb is pointing, and you align your fingers with the magnetic field. A lot of times magnetic fields are drawn with one line after another, which looks a lot like your fingers. So point your fingers in the direction of the magnetic field, your thumb in the direction that the particle is moving, and your palm will be facing the direction of the force. That is, if the charge you're talking about is positive. Notice there's a Q in here as well. If the charge is negative, then it's reversed. So the force would come out of the back of your hand. If you're talking about current, it's the same thing. Put your thumb in the direction of current flow. Put your fingers in the direction of the magnetic field, the external magnetic field. And then your palm will point in the direction of the force. That is the right-hand rule for magnetic force. Don't forget there will be a second right-hand rule coming up later that will show the magnetic field that's created by a current. So here's an example of a positive charge moving through an external magnetic field. So the way we do this, put your hand in this position. Remember, fingers point in the direction of the field, so that way. Thumb points in the direction of the velocity. Oh good, it's already pointing up. If it were pointing down, I would have to flip my hand. So my fingers are in the direction of the B fields, my thumb is in the direction of V, so that means the force is coming out of my palm, that is into the page. Option 3.